3706, you can write as y dot. When you see y dot, remember that is the differentiation. So if I want to get dy, if I want to get dy over dx, which is equals to y dot, then for this one here, it's going to take n down and x to the power n minus 1. So this means that if I have a polynomial equation whereby my polynomial equation is y equals to, let's say, x to the power 4 plus 2x squared plus 1, then when I get my differentiation, when I differentiate, this 4 will come down, is going to be 4x to the power 3, because we are going to subtract, we are using this formula for polynomial, the 4 will go down, then we subtract by 1. Then here is 2x to the power 2, then it's going to come, this 2 will come down, it's going to say 2 times 2, which is going to give us 4x. But when you differentiate a constant, it becomes 0. So we just ignore it. We won't just write it because it's going to say plus 0. So we're just going to leave it as it is. So now when you have seen that, now when you have seen this one, the way we do, so sometimes you might be given a question where say is y equals to x to the power negative 3 minus 3x to the power 4. So if you want to differentiate this equation, your negative 3 will come down. It's going to be negative 3x to the power negative 3 minus 1 is going to be minus 4. And then your 4 will come down here, is going to be negative 3 times 4 is going to give us negative 12 because of this negative there. Then it's going to be x to the power what? 3. So now you must also, this one I'm done maybe talking, giving you these ones. We also have functions. For example, you might find that you have to differentiate y equals to cos of x. Cos of x. So the y for differentiating cos of x, when we find the differentiation of cos of x, the answer becomes negative sine of x when you differentiate cos x. So if you are given, let's say y equals to cos of 4x. So remember, I'm using x. Sometimes you can be given cos of 40. So our differentiating, when we differentiate this one, we'll differentiate everything there, which is going to give us negative cos of 4x. Then you differentiate what is inside here. This is, you differentiate 4x. And normally when we write it, we write d over dx of what? Of 4x. Then the answer here, when you differentiate 4x, remember, is going to give you 4. So the answer will remain negative 4 cos 4x. So let's say you are also differentiating y, which is equals to sine of x. So y, when you differentiate y, which is equals to sine of x, is the same as cos x, but with no negative now. So the same rule applies when if you have y equals to, let's say sine x cubic, ne? You have to differentiate this. So to differentiate y sine x cubic, your answer will say cos x cubic, then d over dx of x cubic. So now when we have to differentiate this one, x cubic, when we differentiate, is going to be 3x squared. So when we rewrite it, it's going to be 3x squared for this one here, differentiating cos what? Cos of x cubic. So that's how you do it. So when we come to, when you have understand this, let me just give you also for 10. If you have if you have to differentiate, if you have y equals to 10 of x, The differentiation of 10x is equals to sec squared x. So when it's sec squared x, this is how the differentiation is. You must just remember that. So now I'm gonna take you to the rules of differentiation. We have four rules. The first rule that we use is called, we're gonna talk about the product rule. Product rule. So the product rule, it states that if you have a function, let's say it's y equals to x squared plus maybe sine x. So in order for you to differentiate this function, the function, I'm gonna also write it as y equals to, let's say, h of x dot g of x. This is the formula you follow. Then to differentiate this function, you can first differentiate h of x. This is mean prime means differentiating. Then you leave g of x as it is. Then you plus, then you differentiate g of x, g prime of x. Then you leave h of x as it is. So if we have to differentiate this now, then which means my y prime is going to be equals to, I will first differentiate x squared. I will have 2x sine x. Then I will say plus. Then when I differentiate sine, we know that we're going to get cos of x. Then I leave x squared as it is. So if you simplify this, sometimes you can just take out the common factor, which is x. Then we have 2 sine x plus x cos x. So by doing this, but you can even stop here. By doing this, we have differentiated these functions using product rule. So product rule, you must have two functions. We have a function for x squared, and we also have a function for sine squared. So sometimes you might find that, okay, for example, you have to differentiate y equals to x e to the power x. So when you differentiate e to the power x remain the same. So if we differentiate in this, we're gonna start with x is gonna be equals to e to the power x, because x is going to be 1, then minus 1 is going to be 0, e to the power x to the power 0. Then you say plus, when you differentiate e to the power x is gonna remain as e to the power x, but we don't differentiate x, we're just gonna write it as it is. So just by doing this, you have differentiated e to this function. So now when we say e to the power x, it has also some other properties that you need to take into account. So if you have y equals to e to the power x cubic, or let's use 4 now, e to the power x4. So if we have to differentiate this, our y prime is going to be equals to e to the power x4. Then we differentiate what is on top here. So we're gonna find d over dx of x to the power 4. Then when we differentiate x to the power 4, you know that is going to say 4. The answer will say 4. X to the power 3. E is this one, e to the power x to the power 4. So we just differentiated this one. So we also have a function called a linear, ln x. We can call it ln x, or it can be ln t. Let me also use a different alphabet. Let me use ln t. So if I want to differentiate ln t, my y prime is going to be equals to 1 over t. So this is the standard format that you must remember. And this ln t that I wrote, if I don't want to write it in this format, because my function is a function of y and t, it states that I will say dy over dt. dy over dt. So now if I have ln, let's say I have ln of 3 t to the power 4. So when I differentiate this is my y. So when I differentiate this equation, it's going to be equals to 1 over, we follow this instruction, 1 over, we write everything that is there, 1 over 3 t to the power 4. Then we differentiate everything that is there, d over dt. Now is it, I used to say d over dx because we are working on terms of t, yeah? D over dt to the power, in brackets, you differentiate 3t to the power 4. So when we differentiate this will give us 1 over 3t to the power 4. But this one here is going to be 3 times 4 is going to give us 12t to the power 3, because this 4 is going to go down. We subtract by 1. So the answer, if you solve it, you might find that your answer is going to be 12 t to the power 3 over 3t to the power 4. So 12 divided by 4, 3. We know that is going to give us 4. And then t, if according to the rules of exponents, if the bases are the same, and you are dividing, you subtract the exponents. It's going to be t to the power 3 minus 4. This 3 here minus this 4, which is going to be 4 to the power t negative 1. So when you have t to the power negative 1, this is the same as 1 over t. So now we can rewrite this as 4 over t. Is it clear now? Are you fine with this one? What we are talking about?
Yes, I understand.
All right. Okay, no, thank you. Then now we have discussed about the product rule. So now we're going to discuss about the quotient rule. Quotient rule. Quotient rule. So quotient rule, it states that if I have a function f of x, which it can be equals to h of x divided by g of x, then if I want to find my f prime of x, this is going to be equals to, the first thing that you do, you can use a square brackets, or you can just say brackets. If I use my square brackets, I will just say g of x. I write it as it is, then I square it. Then on top here, I will first differentiate h of x, h prime of x. Then I multiply it with g of x without differentiating d of x. Then I say minus, this is just a rule. Then I differentiate g of x, it's going to be g prime of x. Then I multiply it with h of x. Then this is the rule for differentiating using quotient rule. So quotient rule, I will give you example. If I have y equals to, I showed you that 10x equals to sec x. So 10x, remember 10x is the same as equals to sine of x divided by cos of x. So if I want to find my y prime of this one using the quotient rule, I'm going to take brackets. I'm going to take cos of x and I square it. Then I'm going to differentiate sine. When I differentiate sine, it's going to be cos of x. Multiply by this sine, cos is going to be again cos of x. Then minus, then I will differentiate cos x. When I differentiate cos x, is going to be minus sine. Remember, cos x is changed the sign. It's going to be minus sine of x. Then you multiply it by sine x. Sine x. So if we simplify this, this one is going to give us cos squared. Cos squared x minus this minus multiplied by minus negative times negative is going to give us positive. then it's going to be sine squared x over cos. This is the same as cos squared x, this one here. Then, according to the rules of identity, you know that cos squared x plus sine squared x equals to 1. This is going to be 1 over cos squared x. So 1 over sine, the reciprocal of 1 over cos of the reciprocal of cos x, the reciprocal of cos x is the same as 1 over sine over cos x. And 1 over cos x is the same as sec x. So now if I have this is going to be the same as sec squared x, which is the same as the one I have gave you before. So now maybe, for example, you can be given a function whereby it says, let's say y equals to, let's say, which one can I do? Okay, let's say x squared over x squared plus 1 plus x plus 1. So if I have to differentiate this differentiation is going to be y prime is going to be equals to, I will first square my x squared plus 1. Then I will differentiate x squared, then I will get 2x. Then I multiply it with x squared plus 1. Then minus, I will differentiate x squared minus 1, which is going to give you my 2x. And negative 1 is just 0. We're going to leave it as it is. Then I multiply it with x squared. Then the final answer for this one, we can take 2x times this one. You will get 2x cubic. And then 2x times 1 is going to be plus 2x. Then this one here is going to give us minus 2x cubic over, you can just write it as x squared plus 1 squared. Then you can see that this one will cancel with this one. Then you will remain with 2x over x squared plus 1 to the power 2. So we have just differentiated it using a quotient rule. So now I'm going to go to another rule. I think you understand this quotient rule now. I will just use this one example. So now when we go to the second one, we're going to go to chain rule. So these rules, like, you just check when you just check the equation that they gave you. So when you check these equations that they gave you, you must see if you have to apply the chain rule or product rule or quotient rule. So, but when you apply them, is you're gonna get, when you get used to it, when you practice, you will just work it out without even thinking of we are using chain rule or what. So let's say you have equation of y equals to x squared plus 1 to the power 3. So the chain rule says if you have equation of x, y equals to a function which I can give it h of x, and this function is to the power n. Then when we find the y prime or the differentiation of is, you take out the n, then you bring h of x as it is, then you n minus 1, then you differentiate what is inside here. What is inside is h prime of x. So if we use this rule here to find this using the chain rule, y prime is going to be 3 in brackets x squared plus 1 close brackets 2 to the power 2. Then when we differentiate what is inside, we're going to get 2x. And when we get 2x, this one here is going to give us 6 x in brackets x squared plus 1 to the power 2. So we have just differentiated using a chain rule. So chain rule also, it can be applied. Sometimes you can get a equation like y equals to square root of x squared plus 2. So square root of x squared plus 2 is the same as equals to, in brackets, x squared plus 2, close brackets, 1 over 2. So when we find the y prime of this, then we're going to say the 1 over 2 will come down. Then in brackets, x squared plus 2 to the power 1 over 2 minus 1 is going to give us negative 1 over 2, which this equation, because of negative, remember when I show you that if you have t to the power negative 1, you can write it as 1 over t. And if you have t to the power negative 3, you can write it as 1 over t to the power 3. Then this equation here, we can write it as 1 over 2. This is this 2 here, in brackets, x squared plus 2 to the power 1 over 2. When we have written it this way, this can also be equal to 1 over 2. Because 1 over 2, we know that is a square root. We can just write as a square root of x squared plus 2. So this is the differentiation of that one using the chain rule. So now I'm gonna go to implicit differentiation. This one is very important because you are using implicit in that module. When you have a function, it can be a function of f. This is where it comes now, whereby now you have to pay attention. You will have a function, it can be f of x and y. So now when we have this function of x and y, we are working in a function of 2 dimension, 2D. So the function of 2 dimension, it can be, for example, we can say x squared y plus, let's say, y plus x. So if you just have to differentiate this function here, if you have to differentiate this function, when you differentiate it, sometimes you might find that I'm not going to use f prime, I'm going to use y now. You might find that you are saying y equals to x squared y, I'm rewriting it, y equals x squared y plus y plus x. So when we differentiate this function, if you are differentiating y, this y, when we differentiate it, it becomes dy over dx. That's why when you say a function, if you remember, when I say y equals to x squared, when we differentiate this, we say dy over dx equals to 2x. So this dy over dx is because of we differentiated this y. So now this y is going to say dy over dx equals to 2x y. Because it's two function here, we started by differentiating 2x. We are using product rule. Then I have to say 2xy plus, then I will leave x squared as it is. Then I differentiated y. When I differentiated y, it's going to say dy over dx. Then when I come to differentiate this one here, it's going to say plus dy over dx plus 1. So now when we have done, you can, because here this is implicit, we can group the one with the like terms like this one and this one and this one. Then we can take it to the other side, which is the left side. I'll write dy over dx minus x squared dy over dx, then minus again dy over dx, this y, which is equal to 2xy plus 1, 2xy plus 1. Now when we have done this, this one obviously speaking is gonna subtract with this one. Then we're going to be left with negative x squared dy over dx equals to 2xy plus 1. Then you can divide by negative x squared. When we divide by negative x squared, our dy over dx, is going to be equals to 2xy plus 1 over negative x squared, which you can just rewrite it as negative 2xy plus 1 over x squared is still the same. So this is the implicit differentiation. So in terms of implicit differentiation, you can get a function y, or you can get a function, I can even use f of x. Let's say I use f of x and y, which is equals to x squared y plus y squared x plus 3. So in this function, the question say differentiate with respect to x. So when I differentiate this with respect to x, my f prime of, you write x to indicate that you are differentiating with respect to x, is going to be equals to, we only differentiate where there is x, which means I'm going to differentiate 2x. We're going to have 2xy, but plus I want to use co-product rule because y is going to be as like a constant. When I come here, I'm going to have plus x plus y only, because when we differentiate x is going to give us 1, y squared. So the 3 is a constant. So let me show you with a different example again, so that you can see what exactly is happening. If you have f of y, which is equals to, let's say, x to the power 3 y plus y to the power 4 plus xy y. Then if I have to differentiate this with respect to x, our f prime of x when x into y is going to be equal to, you take 3 down because we are differentiating with respect to x, is going to be 3x squared y. But this one here, because we are not differentiating with respect to x, it's like 0. You leave it as it is. You don't write it. Or you can just say plus 0 for now, but you don't have to do this. Plus, then we differentiate x only here is going to be 1, whereby we can just write 1 times y is going to be y. So this equation, actually, it will be in this form, 3x squared y plus y. So this is one here, we differentiate it with respect to x. So sometimes a question can say, differentiate with respect to y. If you have a function, if your function is y, which is equals to, let's say, f of x into y, which is equals to y to the power 3 plus x to the power 3 plus x y squared. Then when we differentiate this with respect to y, our y prime is going to be equals to n to y is going to be equals to, we're going to differentiate this is going to be 3y to the power 2. Then this one is going to be 0. We don't differentiate it because we are differentiating with respect to y. Then we're going to say plus, then we differentiate y here. Y is y squared. It's going to say 2y multiplied by x is going to be 2yx. So now when you understand this, if we are working with the differentiation in this module, so I hope you won't have any problem so far. So this differentiation, I was using this dot name. So this dot, you can be also indicated by D. So this, we call it the operator. So when we talk about the operator, if you have a question, it says d plus 1, like this way. You must know that here they are saying here is the same as writing is as dy over dx plus 1. So if I add here, I say x, like this way. So this is the same as dy over dx plus 1 with respect to what? With respect to x. So I'm gonna move to the questions now. So when I move to questions, maybe you can, if you have any questions so far with what we did now, I'm just gonna randomly select any question. Let me check which one do you want us to select to do now?
Anyone.
Any, okay. Let me just choose randomly. Okay, there is 2012. Let me open this one, the first one there. So here there is a tutorial letter. In this tutorial letter, it says question 1, determine whether the system has a solution or infinitely many solutions. If it has no solution, explain why. Explain if it has no solution. If it has no solution, explain why. Else find the general form of the solution. Okay. Or else find the general form of the solution. So let me see if I can enlarge this. Okay, I can enlarge this. So I'm gonna, let me download this paper so that I can write on top of it. So this question here, which we have here, is when we write, when they say x dot dot, this means that is the second difference is d squared y over dx squared. So if it's only one, like x, if it's only y, if it's only one, x dot, this is the same as dy over dx. So now when we have this equation, we have to know if no solutions or infinitely many solutions. And if it has no solution, explain why. We have to explain why. And if it has solution, we have to find the general formula. So now I'm going to rewrite it in my Word document here. I'm gonna do a small one like that. So we have x dot dot plus y dot dot plus x plus y, which is equals to, let me check, or cos 2t is cos 2t, and then x dot dot plus y dot dot plus 4x plus 4y, which is equals to sine t. So the other thing, the first thing that you must know, if you want to know if the solution is infinitely many solution, or if you want to know that this equation is, this linear system has no solution, we have to find the determinant. So in order for us to find the determinant, the first thing that I will advise you to do is to write first this in terms of D. So here, if we write in terms of D, this is going to be D squared. When we say D squared, if it's 2 dot, it's D squared. If it's 1, it's just D. Then D for X here, it will have this X. We're going to say plus 1. Ne? You brackets them, you indicate that this is X. Then you say plus. Here also you have for Y side, you have what? You have 2 dot. It's going to be D squared plus 1 also. In brackets, you indicate that is for what? Is for Y, which is equals to cos 2t. This is, we can write it as your equation 1. Then we're going to do the same to this one, second one. We have D squared plus here is for X. Ne? We write 4. In brackets, you indicate that is for X side plus this one here is also D squared plus 4y. You write 4, you indicate that is for y. Then this is equals to sine t. So this equation here, it shows already because of this, but I'm going to work it out because of these two. Okay, they are not the same. I thought, but because of one of these, they are the same. It can show that it have many solution, but we must prove that. So this is equation 2. So when we prove that, you write the delta of this determinant of this, you write D squared plus 1. Maybe you can bracket them if you don't want to make a mistake. And also you have D squared plus 1 again. Is this one this side? You have D squared plus 4. And you also have D squared plus 4 again. Absolute value. So our absolute value must be equals to 0. So now when we deal with this one here, we're going to find that you're going to calculate D squared plus 1 in brackets D squared plus 4 minus in brackets D squared plus what? Plus 1 in brackets D squared plus 4. And this equation is given us exactly 0. So when it gives us 0, it means that this equation is degenerated. So I'm going to open a book, something for you, so that you can see what I'm talking about. Do you have a study guide?
No.
Okay, maybe I'm going to send you this study guide. So if you check here, in this equation, in this formula, they showed you that if we will say if you have this function, this is a theorem 1.9. So this theorem, I'm not gonna really go through a lot about it. It says if change in identically is 0, then the system either has infinitely many solutions or no solutions. It have many solutions or no solutions. Then when it proceeds, it say if we will turn to the proof, okay, it's fine. Then we will discuss about that. That's not what I wanted. But let me browse again. I just want some, yes, I wanted this. It says polynomial differentiation, you can see there, is called determinant of a system. The system 1.4 is non-degenerated if its determinant is non-zero. Otherwise, it's degenerated. The determinant of system of non-zero, okay. So this system, we call it that is degenerated, né? As I have told you. So when it's degenerated, when it's a degenerated system, when it's degenerated, then because it's 0, and our answer is exactly 0 because this minus this equals to 0, is either this equation, it have many solutions, or many infinitely solutions. Sorry, many infinitely solution, or this equation, it does not know solution. No solutions. So now the other thing that you can prove that it have many solutions or no solutions, then we can also use, you can also use, because it gives you 0 like this way, you can get the determinant in your memo. Even though I haven't opened it, I know that they are going to say delta of this, then you can use 1 of dt, d squared 1 plus 1. You can bracket them. I'm going to also write this one, d squared plus 4. Then you take this question, this 2 is cos 2x and sin t. We're going to say cos of 2t and sin t. Then when we work this out, this one here is going to give us, it's a cross multiple, whereby it's going to say d squared plus 1 sin t minus d squared plus 4. This one is say you multiply this by minus about the determinant, and then cos of 2t. So this one we must make it equals to 0. When we make that equals to 0, then our determine this one here, we're going to say sine. When we differentiate sine, is going to be cos t. When we differentiate cos t again, it's going to give us negative sine t. So because of d squared, I differentiated this sign 2 times. Then this one here, because here there is 1, it's going to just say plus what? Because of this plus t, sine t. 1, it means that we don't do anything with this t. Then we're going to go to this one again. We differentiate cos 2t. When we differentiate cos 2t, is going to give us, the first answer that is going to give us is going to give us negative 2 sine 2t. When we differentiate this one again, it's going to give us negative 4, because 2 is going to go there. Because sign does not change a sign, it's going to be negative 4 cos what? Cos 2t. Then which means here we're going to write negative 4 cos 2t. Then this 1 times that is going to be plus 4 cos 2t, which is equals to 0. Then here you can see that this minus this one and also this one is going to give you 0. And also if we put plus here, this negative times this one is going to be plus and minus. This one you can see also it's going to still go and give you what? 0 equals to 0. So you can also use this method. You see that you get 0 and you also get what? Even in the first method that I showed you, we also get 0. So it's either you can use one of these to show that it's either it have many infinitely solution. So now when we are getting 0, because we understand, now you can see that this indeed is a degenerated linear system. Then now we are going to solve it. I'm gonna just erase because I don't want to erase everything. I'm erasing. Did you understand this part that we were doing now?
Yes.
All right. So now we're going to go to the second step. So just by doing this step, you already score approximately half of that 13 marks. All right, so let's continue. Then I will write here, it was, what was it at before? Let me see. Okay, it's fine. It was d squared plus a 4 here, yeah. And then here was x again, and minus, this is minus. Why is it minus here? Is it plus, right? It was plus, ne? Yeah, it's fine now. So now we're gonna write this in terms of a question. The first thing that you can do, you can decide which one do you want to solve first. In order for you to do, we can first multiply this equation, the whole equation, by d squared plus 4. So if I multiply this equation by d squared plus 4, you will see something. I will say d squared plus 4. But plus 4 is gonna say plus d squared plus 4 in brackets d squared plus 1 of y side. Then this is equals to, you also gonna say d squared plus 4, d squared plus 4 of what? Of cos 2t. So now if we multiply this one, this equation here, we multiply it by d squared plus 1, we're gonna have, also you can see that we're going to have d squared plus 4 and d squared plus 1 of the side of x, plus everything is going to be the same. You see that d squared plus 4 in brackets d squared plus 1, which is equals to d squared plus 1, now is plus 1, d squared plus 1 of sine t. So now, if we say equation, well, let's assume this is equation 3 and equation 4. If we say equation 3 minus equation 4, you will see that this is going to be 0, which is equals to d squared. I'll just write it as it is, d squared plus 4 cos 2t minus equation 3 minus d squared plus 1 of sine t. Sine t. So this one here, we can rewrite it the other side, but I'm just gonna solve it. So this one here, you will see that if you subtract here, this one, if you subtract, is going to give us 4. If we differentiate these 2 times, it's going to say cos negative 2, the way I showed it is gonna say negative 2 sine 2t. Then after that, it's gonna say negative 4 cos 2t. I already shown you that. And my plus again 4 cos 2t, which already we're gonna say minus. If you differentiate, it's gonna cancel this one and cancel this one. Then minus, if we differentiate sine t, it's gonna say sine t. Then we differentiate again, it's gonna say cos t. When we differentiate again, it's gonna say negative sine t. Then plus sine t. So this, everything there is equals to 0. You can see this one cancel, we get 0 equals to 0. So when we get this answer, it means that this equation, it have no solution. Sorry, not no solution. It means that this equation, if you get your answer that is 0, it means that this equation, it have many infinitely solutions. So I worked out for you without memo, without checking your memo. So let's go to check your memo, how it is. So this is the one, it was question number 1A. Let's go to question number 1. This is the memo. So if you check in your question number 1, you will see that your memo, it's showing you that they did the step that I did. You see that? Then they used the second method that I used. You see this second method that I used to show you that you can use the other one or use the another one. Then after when they use the second method, they got 0, which I got. Then they use that one, the equation, they say equation 2 and equation 3, they subtracted. Then they even tell you that the system has infinitely what? Many solutions, as I've already indicated to you. From equation, they used to show you, they were trying to show you something. This is this step here. It's just that here they factorize, they summarized. They say equation 2 minus equation 1. They use it and they found that x of t is arbitrary function of t. And they just work it out this way. They work it out the other way. Then here they just wrote, but everything here when you combine, you're going to get 0. So which is this part that I did there? The last one that I was doing with you. So do you have any questions? So far when I check the memo and what I did is exactly the same. Do you have any question?
I don't understand the last part in the memo.
Oh, the last part, okay. This last part in the memo, they are saying from equation 2 minus equation 1. You see this equation 2, you subtract by equation 1. Equation 2 minus equation 1. So if you say equation 2 minus equation 1, what are you going to get? You are going to get for, like the way here you see is 3x of t plus 3y of t, which is cos to sine t minus cos 2t. Sine t minus 4 cos 2t. So if you say, if we take this here, this equation, we subtract it, this one here, you are going to be left with what? Okay, let me just show you how it is. If you say, remember, if you say d squared minus this squared minus d squared, you see that you're going to get what? You're going to get 0. Do you understand it now? This one, what I'm
Yes, I
saying.
understand.
Then if you say, because we are starting from 2, so that d squared minus d squared is going to give you 0. 4 minus 1 is going to give you what? 3. And this 3 here, there is x. So it's going to be 3x of t, because this x here is a function of t. Then after that, you say plus is this plus here. You use this one minus this one, is going to give what? It's going to give you 0. But 4 minus 1 is going to give you 3 y of t, which is equal to sine t minus, which is equals to sine of t minus what? Cos 2t. So now when you have this equation, you're gonna go again to the second equation. So this one here, if you change it, your y of t here, if we make y the subject of the formula, your y of t is going to be equals to, you take everything the other side. Let's say you're going to have sine t, you taking this the other side there, you will see that you are going to left with 3y of t equals to negative, this one is going to give you negative 3x of t plus sine t minus cos 2t. Do you get this function? Then you can divide by 3. When you divide by 3, this 3, you're going to get your y of t equals to negative x of t plus 1 over 3 sine t minus 1 over 3 cos 2t. So this function, when you substitute this function here to this equation here, you are going to get 0. Do you get what I'm saying?
Yes, I understand.
When you substitute this, you're going to get 0 the way when I work it out here. We get what 0 equals to. So the way they are writing it, they are trying to simplify for you, simplify it. But your lecture, when they are marking, they will know that the way you do, they don't check that. They will check these steps that I was showing you. So the point is to show that your answer is always 0, is 0, is 0. So that you have many infinitely solutions. So do you have any questions so far?
Can we do another exam question?
Oh, okay. I think even in this one here, if you check something, we are not yet done, because we only did A, we have B. So I think maybe should we proceed with B?
Is this a different section?
No, it's the same question. Remember, we are still on question 1.
Oh, okay, okay.
So it says reduce the system of equation. Reduce the system of equation. This is the system to be equivalent triangular system of the form. Okay, this one we won't do it now because this one applies different strategy that we are working on today. It's the different chapter, which we're going to cover maybe tomorrow. Let me check. We are on 20 day 20. Or tomorrow we are doing, it's Friday, we are doing a MAT 12613. But if you still want us to continue with this module tomorrow, we can swap them. Then we do a MAT 3706 if you don't have a problem, so that you can follow properly. Is that fine with you?
Yes, that's fine.
Okay. So let's check another question so that we can only focus on one thing so that you can understand how we are working it out. I'm gonna close this one here, leave this one. Then let me go to my email again. So we did this first one. Then let me go. Should I go to this one? 2014.
Yes.
All right. So I'm gonna download it. So in this one for 2014, I think. Okay. For 2014, it says determine whether the system, this is the system, has no solution and has many solutions. Okay, it's fine. Let's do it. So I'm gonna write it down is x dot dot minus x dot plus 3y dot dot. Oh yeah, it's 3y dot dot and minus 3y dot, which is equals to t. t squared. So I'm just verifying that x dot 1 minus x minus 3y dot minus 3y equals to 1 over 3 t cubic. Okay, let me check. Is 3 squared? Yeah, it's t squared. So in this equation, the first thing that we're going to do, you do the same method. We are going to say d squared is for this x here, and you also have x here minus d, and you also have what? There is nothing for x. Then you brackets, you put to show that is for x side. Then plus, you can put brackets, is 3 d squared, is for y side now, minus 3. We put the y to show that is for y side. Then you say equals to t squared. This is your equation number 1. Then we come to the second, this one here. We have d minus 1. You see that these two. There is no dot there, we write 1. Then you show that is for x side. Then minus, we have minus d. If you check that, then we cannot say minus, because if I take out minus, I will say write 3 here. If I take out minus here, it's going to say 3d plus, we must say plus 3, so that this negative times this one, it can give us negative times positive, it can give us this negative. Then we're going to put y, then which is equals to 1 over 3 t cubic. This is equation 2. So now when we have this, you can see out that we can check here, we can multiply, we can get the coefficient, the determinant of this matrix, Then I will just write this one here and this one. Or you can also use, I can just decide, I say d squared to show you minus d. I use t squared. Then I will use also d minus 1. Then I will use 1 over 3 t cubic. So when I get this one here, I will multiply this times this is going to be d squared minus d 1 over 3 t squared, sorry, it's cubic. And then I will say minus is going to be d. This is d minus 1. Why am I using minus here? Do you know why? Do you know why I wrote minus here?
No.
All right. So when we are working with determinant, let's say it's determinant of, it's like a matrix. Ne? We put a matrix of A, B, C, and D. So the rule says that you must say, is this one multiplied by this is going to be AD, and this one multiplied by this, then it's going to be, it's like minus CD. This is the rules. That's why I say minus D1 minus 1 multiplied by what? T squared. Here I'm going to write T squared. This is the formula for finding the determinant. So let's say example, maybe here it was negative, ne? Negative B.
I understand.
You understand now, ne? Then if it was negative, it was going to be positive here because it's going to say minus, minus. Then this was going to be plus. So if you understand, then let's proceed. So now with this one here, you're going to see that our answer, if we proceed with this question, we're going to differentiate these 2 times. The first time is going to say, if we differentiate, is 2 over 3t. Then the second time I'm going to have 2 over 3. So it's going to be 2 over 3. Then we differentiate once again with this one d, because this is d now. We have minus 2 over 3t. Minus, we differentiate this only once. This t squared once is going to give us t, 2t, And then we multiply by this is going to be plus, negative times negative is going to be plus t squared. Ne? So if you check here, our answer here is going to give us something like, let's say t squared minus is going to give us t squared. Then we can subtract these two here, 2 over 3, maybe let me just use 2 over, you can also use your calculator, minus 2. This is the same as 3, or you can just say 3 times 2 minus 2 is going to be, 3 times 2 is going to be 6, which is going to be minus 2 minus 6 over 3, which is going to be minus 8 over 3. Then here we're going to write minus 8 over 3t for these two, then plus 2 over 3. So now here we didn't get, what? We didn't get 0. So when we don't get 0, it means that this linear system is non-degenerated. So when it's non-degenerated, then this system, it means that it has no. So we can prove that. When we prove it that way, you can also indicate, if you don't want to use this method, you can also use only the D and D and D and D. So now we can find this equation when it says it's not many, like it does, is like this equation. It means that it's going to have a solutions, but it's going to have a equations. We can find a general equations for these solutions. We can find a general equation for this solution. So, but if in this question that we are doing, exactly where I ended, if you end there, they will give you a full marks. So let me go to your memo. I want to show you something before we proceed. So this is the question. Okay, it's question number 1A. And they say, let me read the question so properly. Okay, they say it is has no solution. Explain why, else show is okay. So now we're gonna go to your memo. In your memo here, we used, okay. Maybe I'm not sure if the way I wrote it there, we did exactly the same thing. Do you see that? So in your memo, they end up getting 0. So I'm not sure if there is something wrong with my calculation there. Oh, yes, I see. Do you see what is the problem? I use 1 over 3t squared, not 3 cubic. You see that here. I was supposed to be using 3. That's why we didn't get the right one. So we can just change here over. Let me just change small things there. But I think now you are getting the idea what's happening, right? All right. So now this one here, okay, let me also erase this part. Because everything that we did is fine so far. There is no problem here. So it's just that my calculation were not right. So we're going to say d squared, the way I was showing minus d, and then 1 over 3 t to the power cubic. I was thinking it's squared there. Then minus is going to be d. D is going to be d It's gonna be d minus 1, and then it's gonna be t squared there. Are you still here?
Yes.
Okay, so now we're going to differentiate this. If we differentiate this, we can put out, this is going to be like the first one, remember, is 1 over 3. If we differentiate the first time, it's going to say 3t squared, ne? Which is going to be just s equals to t squared, because this 3 will cancel with this one. When we differentiate the second time, it's going to say 2t squared. So when it says 2t, not squared, 2t only, then here we can write, for this one, we can write 2t. Then we go to the second one. The second one, when we differentiate, we got t squared is gonna be minus t squared for the second differentiation, first differentiation. Then we come to this one, is minus. Then if we differentiate t here, it's going to say 2t. Then this one times this one is going to be plus t squared, because it's just 1 here. T squared plus t squared. So this one here will cancel with this one, and this one will cancel with this one. Then the answer is going to be 0. Then the moment when the answer is 0, it have many, infinitely, or you can just say infinitely many solution. So when you have written this method this way, you can just come here to your equation. For example, if we substitute this, here we got that is 0. So if I make my y, I can change this one to be the other side. This equation here, I can say this one is going to be going to the other side. Then, which means I'm gonna be left with, okay, I want to see this part when I'm working. Let me erase this part here because we are done with this one. Okay, erase. Oops. All right, I already erased, but it's fine. I'm gonna rewrite it. It was d minus 1 of x minus in brackets d3d plus 3. Yeah, we said plus 3 there of y side. Okay, yeah. So now we can change one of these here. Remember, if you say this one minus this one here, it won't work. You see, if you subtract here, if we want to subtract, we're going to left with d. And if you subtract this one minus this one, is going to be, if we say equation 1 minus equation 2, then it's going to be d squared minus 1 plus equation 2. This one plus this one is going to be 0 minus 1. This is for the side of what? Of x. Then you come this side here. This one minus this one is going to be, this one plus this one is minus here. Going to be minus, is going to be plus 3d squared. Then this one, and then we have 3 there. This 3 minus plus this one, because it's gonna be plus, gonna be 0 minus 3d, which is equal, is for the side of what? is for the side of y, which is equals to this one minus this one, gonna be t squared minus 1 over 3t cubic. So now, when you have done this way, we can now differentiate this. X is gonna be 1, x of t is gonna be 1. Then we're going to left with minus x of t, because it's going to be 0. Then when we differentiate this y here, you're gonna see that it's going to be 1, it's gonna be also 0, but we're gonna be left with minus 3 y of t, which is equals to t squared minus 1 over 3 t cubic. So if we take this x the other side, your minus 3y of t is going to be equals to t squared minus 1 over 3 t cubic plus x of t. Then you can divide by minus 3, then your y of t is going to be equals to negative 1 over 3t squared. This one, 1 over 3 divided by or multiply by 1 over 3, going to be plus 1 over 9 for this one, t cubic, and then minus 1 over 3 x of t. Then just by this, you are done. You just end here. But sometimes if you don't write this is not really necessary. So even if now we go to your memo there, let me see if they indicated it. Okay, as page, you can see we got 0. It has many infinitesimal solutions. Then they got exactly, you see what I got there. 1 over 3 tg, okay. This one here, I'm not sure if it's the same solution. Yeah, x of t, let x of t plus 3 of t equals g of t from some what, okay. B minus g of t equals to 1 over 3t. Then hence g of c complementary functions e of t. Then they get that 1 over 3t what, okay. So in this one here, they are using, let me check why. All right. So I'm not understanding really your memo. I'm gonna work it my own way, the way that according to how you're supposed to do it. Let me just check what I did there. Okay, the way I did it here, it gave us something 1 over 3t, 1 over 9, which is not the same way as that one. So I'm gonna use the different way. Let me just erase this part. This one is just to prove there is nothing much that is need to be done there. But if you end at determinant, they're supposed to give you a full marks results. So the memo sometimes it's just a good way for guidance, but there are steps that they use. Sometimes they've eliminated a lot of things. So when you have done this way, when we're in this when we are in this scenario, this one, what you're going to do, you are going to eliminate. We are going to use this side. We have d minus 1 here. This side we have d. You are going to multiply. You must multiply with this equation with d minus 1. Then if you multiply with d minus 1, you're going to have d minus 1 and d squared minus d of x, then plus d minus 1, d minus 1, and then 3d squared minus 3d squared, d minus 1, 3d squared minus of y side, which is equals to t, which is going to write d minus 1 of t squared. Then this one we can make it equation 3. Then you multiply this one with d squared, is going to be d squared minus d, then d minus 1. This is the side of x, minus, then you d squared again, minus d, in brackets, 2 is 3d. This is 3d, ne? 3d minus d. Is it plus? Yeah, it's plus d. Let me verify that. Because it's minus. Yeah, it's plus d there. Plus, not plus d, plus 3. Sorry. Plus 3 of y side. Then equals to 1 over 3. You're going to say d squared plus d. Is it minus? Sorry, minus d. We are multiplying by minus d. In brackets, what? 1 over 3 t cubic. So this one, if we say we're subtracting this one minus this one will cancel with this one. Then if we say this one minus this one is going to give us equation, I'm going to say equation 1, equation 3 minus equation 4. Then this will cancel with this. This one minus this one is going to be plus here. So it's going to say d minus 1 in brackets 3d squared minus 3 plus in brackets d squared minus d into 3d plus d, ne? Which is for the side of what? Everything here is for the side of y, equal to this one minus this one there. We can now, before you can do anything, we can just now, we say we differentiate t. If we equals to, you can just write 2t there minus t squared for this one. Then for the second one, we differentiate. This one is going to be, this one minus that one is going to be minus. This one, when we differentiate, we're going to get 3t squared. Then we're going to get 2 minus 2t. Then when we differentiate this one, only once we're going to get plus t squared. Ne? Whereby this will cancel with this will cancel with this. Then your answer here is going to be 0. Then when our answer is 0 here, we are going to just do some few things a little bit. We are going to multiply back everything there. You're going to get this one times this one is going to be 3. This one times this one is going to say 3d to the power 3 minus d times 3 minus 3 minus 3d. This one minus 3d squared plus 3. Then you multiply, let's say plus d times 2 is going to be 3d squared. 3d squared, and then this one times this one is going to be 3d squared, is going to be plus again d squared minus 3d squared, and then minus d squared. Then this is in the form of y, remember that, and everything here we know that equals to 0. Then after that, we're going to group the like terms. So if you check here, we have many squared here. We have this one here. I will just write 3d to the power 3. Then we're going to start solving this one for d squared. It's minus 3d squared plus this one will cancel with this one if you check that. and this one will cancel with this one. Then we're gonna be left with minus 3d squared. This one we already wrote it there. Then you're gonna check here, we have minus 3d, and we also have minus 3d. Is this one already wrote, even this one, and plus 3. Everything here is in terms of y, which is equals to 0. So now when we have this, we can differentiate y here with this one here. We know that this one is going to give us this equation here is going to say y, the right side, we're going to differentiate it. We are going to get, we're going to differentiate y is going to be y 0, 0. It's going to be 0 here. Then we differentiate this one, which is going to give us minus 3y, and when we differentiate 1, 0, it's going to be minus 0 again, then minus 3 here, because it's going to be 1, and minus plus y, which is equals to 0. So after this one, our y is going to be equals to 3. So we got y of t. Our y of t equals to 3. When we get our y of t equals to 3, then we can substitute in one of these equation, in equation 1. We will substitute y of t in equation 1. When we substitute y of t in equation 1, let me erase y of t equals to 3. So if I substitute in this equation number 1, I will use this one. My y of t equals to 3. I'm going to have a d minus 1 of x. Then plus, here we put 3. It's going to be 0. And then here when we put 3 again for y, it's going to be minus 3. It's going to be 0 plus, in brackets, minus, let's say minus 3 times 3 is minus 9, equals to t squared. So now we're going to take this d minus 1 of x to be equals to t plus 9, t squared plus 9. Then this one here is going to give us, d is going to give us 1 minus x of t, which equals to t squared plus 9. Then minus x of t is going to be equals to minus, that side is going to be 8, which is minus, it's going to be 8. Going to be minus, okay, yeah, if we put plus, it's going to be minus t squared minus 8. So the answer solution that I'm getting there is 8. Let me see which solution did they get there? Now for this one, we are getting the different one when I'm using my method. Also, we are not getting the same. Let me just check the g of x of t plus 3 of t equals to g of t.
I think
Let me check this.
we should do
Hello?
this. Hello, can we do this question for the next lesson?
For the next.
Lesson?
Oh, okay. But there is, okay, we're gonna do it next lesson. But there is something that you see here, this function that they wrote here. It have x of t plus 3, whereby when I check here in what I did, because I have x of t, there was y of t, I have x of t, 1 minus x of t. So something, maybe some calculation somewhere, somehow, very small mistake. Then it's fine. We're gonna do it next tomorrow. All right, then I will see you tomorrow.